Hey guys, it's Miss Mitchell, and I'm here to do a Chapter 3 study guide walkthrough. You guys seem to really appreciate the 9 weeks test study guide review, so I'm going to start doing this for all of our tests now. So hopefully this helps you. Sometimes seeing the answers doesn't give you quite as much grasp as seeing it worked out. So we're going to go through the Chapter 3 study guide. This should be available for you to print on Schoology if you haven't already. Please follow along with me and write through and write the answers. That way you guys have some study material to look back at, okay? So we're going to go ahead and get started. All right, so it says to use the tile pattern at the right to answer the questions. So let's figure out what we've got going on here first. So we've got 2, 4, 5, 6, 7, 8, 9, 10. We've got 11 on figure 1. And then we've got, give me a second to count, 16 on figure 2. I'm sorry, 17. And then on figure 3, this is going to take a minute. 23 on figure 3. So then we need to figure out what's happening from each figure. So we go from 11 to 17. So that means we're adding 6. And then the same thing here, 17 to 23, once again, we're adding 6. So we could assume that figure 0 was minus 6 and figure 4 is going to add 6 more. So we're counting by sixes essentially. So we can go ahead and complete the table. And let's use figure 1 through 3 first. So we know we've got 11, 17, and 23. And then for 0, we'll subtract 6, so we'll have 5. And then we'll keep adding 6, so we'll have 29. 29 plus 6 is going to give us 35. 35 plus 6 is going to give us 41, and 41 plus 6 is going to give us 47. So all we're doing is just adding 6. All right, now we need to write our equation. So first thing that we need to figure out is what is our m, and then we need to figure out what is our b, and then we can write our equation. So our m is our rate of change or our slope, and in this case we're adding 6, so that is going to be our slope here. It would technically be 6 over 1, which we know is just going to be 6. And then our b, this is our y-intercept. So in order to find our y-intercept when we're looking at a table, we need to find an x value of 0. So our x value of 0 is here. So that means 0, 5 would be our ordered pair, which means that 5 is going to be our b. So now we've got our slope, we've got our y-intercept, and we can write our equation. Remember, our equation, let me see where I can put this, is y equals mx plus b. So we would have y equals 6x plus 5. All right, now it says how many tiles are there in figure 23. So notice that our figures, these are figures, are our x. So that means we can solve for 23 by plugging in for x. So we would do y equals 6 times 23 plus 5, and we would get 6 times 23 plus 5 is going to give us 143 tiles. Make sure you're answering that in the correct unit. It's asking us how many tiles there are, so we need to answer it. There would be 143 tiles. All right, number 2 says to evaluate the function with the given information. So once again, hopefully we've got these down by now, but we're trying to figure out, are these inputs or outputs, and then we're deciding if we're plugging in for x or we're plugging in for f of x. So remember, if it's in parentheses, it's an input, and if it is outside of the parentheses, it's an output. Okay, so here we've got f of negative 3. This is inside the parentheses, so this is an input. F of x equals 5. This is outside of the parentheses. This is an output. F of negative 10 is inside the parentheses. This is an input. And f of x equals 23 is outside of the parentheses, so this is an output. I like to go ahead and do that before we solve, just to make sure we understand what we're doing. So for our inputs, we know that we're plugging in for x, and for our outputs, we know that we're plugging in for f of x, okay? So for number 1, we would plug in, so we'd have y equals 15 minus negative 3. Watch your signs here. and we'll get y equals 18. F of x is equals 5 is an output. So we're going to put that in on f of x. And you can kind of understand that by saying that f of x equals 5. So we're just replacing f of x, right? So we would have 5 equals negative 3x minus 7. And now we're going to solve for x. So we would add 7 to both sides. We get 12 equals negative 3x. We want to get x isolated, so we're going to divide by negative 3. 12 divided by negative 3, x equals negative 4. All right, C, we've got f of negative 10, which we have established already as an input. So we're going to plug in for x. So we'd have 8 over negative 10 minus 4. All right, well, don't worry about this being a fraction just yet. Let's just work out what we've got. So we'd have 8 over negative 14. Negative 10 minus 4 is a negative number. And then 8 over negative 14 can be reduced or simplified to negative 4 over 7. And notice I moved the negative sign up, but it doesn't matter if it goes in the numerator, denominator, or out to the side. This whole fraction is negative. All right, and then D, we've got f of x equals 23. This is an output. We're replacing f of x. So we have 23 equals 4x minus 5. We're going to add 5 to both sides. We'll get 28 equals 4x. We want to isolate that x, so we divide by 4. And then we get x equals 7. Okay, so just make sure you're doing the right thing with the outputs or the inputs, okay? Make sure you're replacing for x if it's an input and f of x if it's an output. All right, now we've got some graphs to look at. So it says given y equals 5/3 x minus 3. All right, so remember, please never ever forget this equation as long as you're in algebra. Mx plus b, right? This is our slope. We know that m is our slope. We know that b is our y-intercept. So it already gives you those things. So we can pull from this formula what is what. So our slope is going to be 5/3. And notice here it's not asking for b, not b. B would just be negative 3, right? But that's not what it's asking for. It's asking for the y-intercept, which is an ordered pair, okay? Make sure ordered pair. Make sure you write your y-intercepts as ordered pairs always. So we are going to use that negative 3, but we know that we are going to have an x value of 0. So we write it as 0, negative 3. Then it wants us to graph. So how would we graph this? Well, first we'd find our y-intercept. We would have 0, negative 3, so 1, 2, 3. And then we would just follow our slope. So we'd go up 5 and over 3. 1, 2, 3, 4, 5. 1, 2, 3. Okay, and that's really all I'm worried about. 2 points is fine just for the sake of this review. And then we just draw our line. This is a little thick for arrows, but you get the idea. All right, and then B says given y equals negative 4x plus 6. So once again, pulling from this formula, our slope is going to be negative 4. And our y-intercept is not just 6, but would be 0, 6. And then notice this slope is negative, but let's go ahead and graph our y-intercept. So we've got 0, 6. So 0 is our x value, 1, 2, 3, 4, 5, 6. And then we're going to go down 4. And remember that if you have a slope of just like a regular number, that's the same thing as saying negative 4 over 1. So we're going to rise 4 and run 1. But it's negative, so keep that in mind. So we're going to go down 4. 1. We want this to be a decreasing line. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So notice that this is a decreasing line. And that tells us we graphed it right. It's negative, right? So remember, increasing is a positive slope, and then decreasing is a negative slope. So even if you're not sure make sure you're, like if you're not sure how to distinguish what you should be doing, if it's negative, your line should be decreasing, okay? All right, number 4 says to find the slope for each relation, and A gives us 2 ordered pairs. Well, hopefully we have the formula memorized. M equals y2 minus y1 over x2 minus x1. This is how we find the slope when given 2 ordered pairs. So remember, we've got x and y, and then this is our first, this is our second, so we'd have x1 and y1 and x2 and y2, and then we just plug it in and solve. So we would have 12 minus 5 over 3 minus negative 4. Make sure you watch that carefully. All right, and then 12 minus 5 is going to give us 7. And then 3 plus 4 is also going to give us 7. So our slope is 1. And that's all you got to do. All right, now it wants us to find the slope for B, which gave us a table. And remember, we subtract up to find our slope. Meaning we're going to go 18 minus 13 gives us 5. And even if you think it follows the pattern all the way up, double check. 13 minus 8, 5. 8 minus 3, 5. 3 minus negative 2, 5. So that's 3 plus 2. Negative 2 minus negative 7, also 5. Watch your signs there, okay? And then on the top, we've got 1 minus 0, 0 minus negative 1, 1 minus negative 2, negative 2 minus negative 3, and negative 3 minus negative 4. All of these are going to be 1. And remember that our slope is rise over run. And the variables we look at for rise is where it's rising on the y-axis. So y, y, and then run is where we're moving left to right on the x-axis. So our slope is y over x. So we would have 5 over 1, which would just equal 5. So our slope is 5. Okay. Let's keep going. All right, so now we're talking about, is it a function, discrete or continuous graph, the domain, and the range. Okay, so first things first, is it discrete or continuous? Well, we know if it's got a line, it is continuous. Is it a function? Does this pass the vertical line test? Yes, it does. So if we're doing a continuous graph, we're going to list our domain and range in algebraic notation. Okay, so continuous equals algebraic notation, and then discrete is just going to be list the ordered pairs, x and y values. All right, so now that we've got that, we need to talk about the fact that these have open circles. So this means that it does not equal this last number, right? So our domain is our x and our range is our y. So for domain, we're looking at x. So we're coming across left to right from least to greatest. So our first x value is negative 5. And we keep going. Our last x value is positive 4. But because these are open circles, it's going to affect the way we write this notation. So we would have negative 5. It's an open circle, so we're not going to include the equal sign. We're just going to do less than, not less than or equal to. Then we put x. Same thing for 4, less than 4. All right, now let's talk about range. We're looking at y. So we're going to start the same way we did for the negatives on the x. We're going to start at the negatives on the y. We're going to work our way up. So our first y value is negative 3. And our last y value is positive 4. But once again, these are the points that have open circles, so we're not going to use less than or equal to. So we would have negative 3 is less than y is less than 4. All right, B, is it discrete or continuous? This is continuous. It has a line. Is it a function? Does this pass the vertical line test? Yes. All right, now we need to notice that these have arrows, okay? So that means there's part of this graph that we don't know what's happening to, right? So, once again, we're looking at x and y. So our domain, our first x value, well, this arrow goes off, so we don't know that first x value. So that first x value is infinity. and then we keep going, and our last x value also goes off the graph. So once again, our last x value is infinity. And if we have a first and last value of infinity, we equal all real numbers. So in this case, x equals all real numbers, okay? That's a terrible symbol, I'm trying. Close enough. So now we need to look at our range, which is our y, and we start from bottom to top. And our first y value is right here, and that's going to be -4. Oh, my pen has a mind of its own. -4. And then our last y value is going to be one of these arrows that we don't know about. So our last y value is infinity. So we would technically have -4. And this is a point on the line, so it's a closed circle, so less than or equal to y. And then infinity is always just less than, so less than infinity. But we know that we cannot have infinity in our notation, so we need to get rid of that. But then we also should know that we can't end with y, so we need to flip that around. So I'm going to write what we've got right here. I'm going to erase this. All right, so we have to flip this, so we would have y is greater than or equal to -4. Okay, now we need to look at C. Is it discrete or continuous? Well, there is no line here, so this is discrete. And it says, is it a function? Well, let's see. Does it pass the vertical line test? No, we've got 2 spots right there that would match at the same vertical line. So no, it's not a function. And then for these, we said to list the pairs x and y values, meaning for domain, we're going to write all of the x values, and for range, we're going to write all of the y values. So make sure you write these in order from least to greatest. Whether you're talking about just listing them all, or if you're making a algebraic notation range, we're still listing it in order from least to greatest. Okay, so we have got, let's figure out what we've got. -6, -2, -3, 0, -1, -4. I'm just writing down all these ordered pairs first. And then we've got, what is this? 1, 2, 3, +3, +2. And this is 0, 5. Here we've got 3, 5. Wait, is that 3? Yeah, 3, 5. We've got one more down here. 1, 2, 3, 3, -1. All right, so now we just need to write that in order from least to greatest. So for x, our least to greatest goes left to right, and you make sure you include these in brackets. So we would have -6, -3, 0, 1, 2, and 3. Okay, if you have ordered pairs with the same x values, which we have 3 here, it seems to be. Oh, no, that's why it's wrong. I knew something looked off. Which I already knew was the answer. That's why I wrote it down here. So we have -6, -3, 0, 1. Oh, is that -1? No, that's +1. I'm all kinds of messing up today. +1. And then we've got 2 and 3. All right, and then our y's, we're going to work bottom to top as well. So we would have -4, -6. Jeez. I'm so sorry, guys. I'm just now realizing I made all these mistakes. It's hard to look at the graph on this little bitty screen. -1. And that's the same ordered pair as over here. So -4, -1. Let's keep going up. We've got 0. Then we've got 2. And 5 we have 2 of, so we just have to write that 1. All right, so obviously, a good point to make here would be to double check your ordered pairs, because I rushed through that and made several mistakes when writing these out. So double check your ordered pairs, but this is the correct answer, okay? All right, now we're just solving for x. So this is easy. Hopefully you remember this from chapter 1. We're just solving for x. So we need to distribute this out. So we would have 4x plus 12 equals 24. And we're going to subtract 12. We get 4x equals 12. Divide by 4. And x equals 3. All right, number 2, we've got a fraction here. So x over 5 minus 2. So the first thing we want to do is add 2 to both sides. And then we'll get x over 5 equals 9. And then to get rid of this 5 on the bottom, this is technically x being divided by 5. So we're going to multiply by 5. And we get x equals 45. Right, C, we've got x minus 4 all over 6. Well, remember that this is a grouping. Even though this is a minus 4, you would not add that 4 first until you get rid of the 6. So we're being divided by 6. We're going to multiply by 6. And then we get x minus 4 equals 18. Right, then we want to isolate x. So we're going to add 4 to both sides. And we get x equals 22. And that's our answer. Right, not too bad. Hopefully you remember that from a couple lessons back. All right, number 7. Find the slope and y-intercept and then write the equation for each relation. So we've kind of already done this. We need to find our slope of a. So we're going to do that by subtracting up. So 7 minus 4, 3. 4 minus 1, 3. 1 minus negative 2, 3. Negative 2 minus negative 5, 3. And so on and so forth. So this side is 3. And then on this side, we've got negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. So we can tell that this is being changed by 1. Okay, sorry, my phone was ringing. So our slope here is going to be, remember, rise over run is y over x. So our slope is 3 over 1, which is just 3. So our m is 3. And then our b is our y-intercept, right? So where's the x value 0, which is going to be right here. And this time, notice it's asking for b and not a y-intercept, so we just have to write that for it. All right, and then our equation, we're just going to put all these together. Remember, it's y equals mx plus b. So we would have y equals 3x plus 4. All right, and then b, we've got a graph, so we have to figure out what is going on in this graph. What's our slope? So that's the first thing we need to talk about. So notice, first things first, we're decreasing, which means we're going to have a negative slope. All right, so let's find 2 points. So here's a point, and here's a point. So we're going to go make our triangle, and we're going down 1 and over 3. So our slope is negative 1 over 3. All right, and then b is our y-intercept. Where are we crossing this y-axis? It's right here, which is positive 2. All right, now we just need to write our equation. It's going to be y equals negative 1/3 x plus 2. All right, and 8 says, which value of x is excluded from the domain of x equals 3 over 9 plus x? Well, this is just asking us what value of x won't work. And we know it won't work if it makes it undefined. And undefined, if we remember, hopefully we do, could be something where it has a slope of a fraction with 0 on the bottom, because we cannot divide by 0. So if it's something over 0, it's undefined, which means it won't work. So what we need to do for this is find out what is going to make the bottom of this 0. And all that is the opposite of what's there. So if we have positive 9, the answer to make it 0 would be negative 9. All right, so let's keep going. Okay, so now we're getting into some word problems. So hopefully you remember these. We just did this lesson, but I know that these can seem complicated. It is not necessarily complicated. It's just a lot of material that you have to be able to interpret. So that's what we're going to do right now is go over these word problems. right? So it says a bike rental fee is $15 plus 25 cents per hour. How many hours can Kristen rent the bike if she has $20? So let's interpret what we're talking about in here. So we've got to notice these rate words, okay? So we've got per hour. So this, let me write this over here. So rate word could be like every, per, daily, whatever, something like that. That means rate of change, okay? Don't look any further. That is your rate of change. So our rate of change would be 25 cents per hour, okay? Well, we know that, but let's keep going. So let me circle that a little better. So our rate word here, okay? And then a bike rental fee is $15. So $15 regardless of how many hours you are biking, you're going to pay that $15. So that tells us that 15 is our initial value, right? We're initially paying $15, which we should hopefully know is also our B, right? So let's define our variables. We've got costs. We're talking about money, and we've got, so how much can she cost? Bike for 20 hours, and geez, $20. And then we're also talking about hours. So we've got cost and hours. Well, more often than not, cost is always going to be your dependent variable because you can't have a cost without something else taking place. So we can put hours as our x variable. All right, so now let's write our equation. So if we know that our rate of change is 25 cents per hour, we know that that is our M, and we know that $15 is our B. So we've got 15 and we've got 25. So that is going to be our equation. So let's just fill it in. Y equals 0.25x plus 15. All right, and then we need to answer the question. So it says, how many hours can Kristen rent the bike if she has $20? Well, we know that $20 is going to be our Y value, right? Because cost. So that means we're plugging in for Y. So let me erase this. So we would have $20 equals 0.25x plus 15. We would subtract 15 from both sides. We're solving for x. So we'd have 5 equals 0.25x. Right? And then we're going to isolate that x, divide by 0.25. And we get 20. So the solution is 20 hours. 20 hours. She can bike for 20 hours if she has $20, and we know that because that is our Y variable, so we just plugged 20 in for our Y in our equation, okay? B, a 12-inch candle is burning by 1.5 inches per hour. After 4 hours, how tall would the candle be? Well, let's find that rate word, per. So we've got burning by 1.5 inches per hour. And the reason that I also highlighted burning is because this is a word we need to know means negative. We are losing 1.5 inches per hour, okay? All right, and then it says that the candle started at 12 inches. So this is our initial value, which is our B. And then our variables are going to be probably what? How long it's burning and how tall it is. So let's think about what depends on the other. Remember, Y is our dependent variable and X is our independent variable. So which one depends on the other? Well, hours does not depend on the inches of the candle, but the amount of candle left, or inches of candle, does depend on how long it's burning, right? So how many hours it's burning. So hours is our independent variable. This is what's causing the change. And Y is inches. Okay, so now let's write our equation. So we'd have Y equals, M is our rate of change, which is 1.5 inches per hour, so 1.5x. And then, negative C, look, make sure we're writing that as a negative because we're burning. And then initial value is 12, so plus 12. Negative 1.5x plus 12. Then it says, how tall will the candle be after 4 hours. So 4 hours is our x variable, so we're going to plug in for x. So we would have negative 1.5 times 4 plus 12. And when you work this out, you would get y equals 6. So our solution, make sure you're writing this in the proper units. It's going to be 6 inches because it wants to know how tall will it be, and that's its height is given in inches, okay? Let's see. So now we have to find the slope of some word problems. So we've got a line with a slope of -2, and it's passing through points 3, 7. So to write our equation, we need m and we need b. So we know our m is -2, but we need to find b. So we can solve for b by plugging in x, y, and m into y equals mx plus b, right? We can isolate b. So we can do that by saying 7 equals -2 times 3 plus b, right? And that's going to give us 7 equals -6 plus b. We want to isolate that b, so we're going to add 6 to both sides, and we get 13 equals b. So now we know b equals 13, but that is not our answer. It wants an equation. So now we've got m and we've got b, and we can write our equation. It's going to be y equals m -2x plus b plus 13. So -2x plus 13. Right? Alright, so 11 says to find the equation of a line that passes through the points -4, -2, and -3, 5. So in this case, it gave us two ordered pairs. So we need to use the slope formula, y2 minus y1 over x2 minus x1. And we're just going to plug that in. So we'd have 5 minus -2 all over -3 minus -4. And 5 plus 2 is 7. -3 plus 4 is 1. So we have 7 over 1, which is just 7. So we've got m equals 7. But now we need to find our b. We still don't know b, so we're going to solve for that using one ordered pair and our slope. So I'm going to choose -3, 5 to solve for that using my x and y. And then we're just going to plug that in. So we would have, remember we're using y equals mx plus b. So we would have 5 equals 7 times -3 plus b. 5 equals -21 plus b. To get rid of that -21, we're going to add 21, and we get 26. So b is 26. So now we know our slope, and we know our b, and we can write our equation. So it's going to be y equals 7x plus 26. Okay, let me scroll this up a little bit. All right, so we've got the range of a function, and it wants us to find the domain. So remember that range is our y value, or an output, and domain is our x value, or an input. So it gave us a range, and it gave us a function, and it wants us to find the domain. So all we're doing is plugging in these numbers for y to solve for x. So, for example, I'm going to do 31, and I'm going to let you guys do the rest, but I'm going to show you how to do it. So we're given our output. So we would have 31 equals 2x plus 9. We would subtract 9 from both sides. And so we have, sorry, my papers are in the way. So we have 31 minus 9, which is going to give us 22, equals 2x. We divide by 2. Sorry, I'm kind of going over this next problem. So 22 divided by 2 is 11. All right, and then you would do the same thing for all of these numbers, and you would label your domain, that's what you're listing, and include it in brackets. So we would have 11. If you worked out 23, you should get 7. For 15, you should have 3. For 7, you know what? I am all over the place, and I'm really sorry today. I did not mean to be so messing up. That doesn't even make sense. What am I trying to say? Anyway, so we know that our answer is 11. So for 31, you'll have 11. For 25, you should have 7. For 15, you should have gotten 3. 7 should give you -1, and 1 should give you -4. So now we need to write this in order from least to greatest, which would be the same way we have it up there: -4, -1, 3, 7, and 11. Okay, I'm going to erase this since I kind of wrote on the next problem. Now we're given the domain, which is our x value, and we're looking for the range, which is our y value. Notice it gave us our domain in algebraic notation, which is just a range. So we've got -2, -1, 0, 1, 2, and 3, right? All of the numbers between -2 and 3. So to find the range, remember we are given our domain, which is inputs. So we're just going to plug in for x. So I'm just going to do -2, and then you guys do the rest, but I will give you the answer. So we have -4 times -2 plus 5. -4 times -2 is going to give us +8 plus 5. It's going to give us 13. Okay, so for -2, we should get 13. For -1, we should get 9. For 0, you should have 5. For 1, you should have 1. For 2, you should have -3. And for 3, you should have -7. So make sure you label your range and include it in brackets and list it in order from least to greatest. So you've got -7, -3, 1, 5, 9, and 13. All right, 14, my personal favorite. Describe the transformations compared to the parent function y equals x. So we hopefully know that this is y equals 1x plus 0. None of that is necessary. That's why it can be shortened like that, but that's what we're comparing it to. So we need to look at our slope. So notice we went from 1x to -2x. So first things first, we changed signs from positive to negative. So that negative tells us we have a reflection. Right? And then our slope went from 1 to 2. So 2 is bigger than 1. When we're looking at slope, if it's greater than, we're looking at steeper or flatter. So greater than is steeper. Right? And then we went from 0 to 5. This is our y-intercept. So that means we went from 0 on the y-axis to 5. So that means we have a vertical shift up 5. All right, for b, we went from 1 to 1/2. That 1/2 is smaller than 1, so we are going to be 1/2 times flatter. Then we went from 0 to -4. On the y-axis, that means we moved down, so that's a vertical shift down 4. All right, and then c is y equals -4x, so we went from 1 to -4. So first things first, our sign changed, so we have a reflection. Then we went from 1 to 4. 4 is greater than 1, so we are 4 times steeper. And then 0 didn't change, so that's all that happens there. All right, 15 wants us to find the slope of each line. So let's go ahead and do that. So let's start with A. So we can make a point. Remember, we need to find 2 points. So here we go. And where's the next point? Right here. And then make our slope triangle. So we're going down 1, 2, 3. And notice this is a decreasing line, so it's a negative slope. And we're running 1, 2. So for A, our slope is -3/2. Okay. B, you should know by this, hopefully you know that a vertical line is always, vertical line is always going to have a slope of undefined. Okay, so B is undefined. Okay, and then C, let's find C. We've got a point right here and a point right here. Let's make our slope triangle. So we're going up 1 and over 3. And then for D, notice we've got this horizontal line. Which is always going to have a slope of 0. Okay, I kind of remember that as like horizontal has the letter O in it, which looks like a 0. So if it's a horizontal line, it's always going to be a slope of 0. And if you're not sure how to tell horizontal and vertical lines apart, hopefully you are, but remember the horizon is how I remember horizontal line, okay? So now it asks us, which line is the steepest? Well, is it going to be A, B, C, or D? So the steepest is going to be which one's the greatest. And in this case, B would be our steepest, right? Because imagine these being some slides that you're going to slide down. This would be the most scariest one, right? This would be terrifying to just go down a completely straight slide. So steepest is B. And then least steep, I think of this as which is the least boring, right? Like which is going to not move you at all. I don't know why I said least boring. I am literally all over the place. I'm sorry guys, it's Monday. I'm just using my off time to get some work done, and I'm clearly not in full school mode. So please excuse all of my rambling and mishaps and whatnot. But the answers are right. So anyways, the least steep, what is the most boring slide? Is like what I like to ask myself. It's definitely going to be D. Right, and then it says, does A have a positive or negative slope? Well, we already wrote that down, but we can double check that A is decreasing, so it is going to be negative. Okay, let's keep going. We're almost done, and hopefully you've made it through this entire thing with me. If you have, congrats. You deserve a pat on the back because I don't know that I can make it through this video myself. But anyways, number 16 says to identify the rate of change and the initial values for the situation. So remember that now we're just talking about real life problems. That's why we've started calling it rate of change, but we're still looking for, a slope essentially, right? So it says the amount of profit in dollars depends on the number of tickets sold. So clearly, number of tickets sold is our dependent variable, so our y, and then the profit is our x. So we know that. And it listed over here, so this will be the same thing, say x and y. So now we need to find our rate of change. Don't let the fact that this is a word problem throw you off. All we're doing is finding the slope just like we would of a regular table. 12 minus 9, 9 minus 6, 6 minus 3. All of these are going to be 3. Okay, 18 minus 13.5 is 4.5. 13.5 minus 9 is 4.5. 9 minus 4.5, 4.5, shocker. So our rate of change, remember, is y over x. So when we're talking about rate of change, we're not talking about equations, so we need to convert this decimal to a fraction. So 4.5 over 3 is going to be 3 over 2. And what this is telling us is we're making $3 for every 2 tickets, right? Because we put 4.5 on the top, so that's our profit, and 3 on the bottom was our tickets. So our rate of change is going to be $3 for every 2 tickets. Okay. Our initial value, remember, is our y-intercept. So we need to find an x value of 0. Well, notice we don't have one, but we can find one, right? So 3 minus 3 would give us 0. So then 4.5 minus 4.5 would also give us 0. So this is going to be our y-intercept. So our initial value is $0. And you can think about this logically, because if you haven't bought any tickets or sold any tickets, you have no profit, you have no money. So that's why our initial value is 0. All right. Kevin started a savings account at Christmas by depositing the money his grandparents gave him. His savings account balance changed from $1,140 to $1,440 in April. Find the average rate of change and the amount he originally deposited. All right, so we need to break down a few things in this problem. So he started a savings account at Christmas. All right, this is going to be the month of December. Right, so just like we did those figures in the very first problem, this is month 0, right? And then it says in January he had $140 1,140. So January is going to be month 1. And then it says $1,440 in April. And this is going to be month 4, right? January, February, March, April, month 4. So just because it doesn't give you all of the options to fill in for X and Y and whatever it may be that you're finding doesn't mean you don't have to find it. So let's talk about our X and our Y variables. So obviously we're looking at months and money. So the amount of money he has depends on how many months he's been depositing it. So X is going to be months, and then Y is going to be money, right? We can't have more money without more months. So to find our rate of change, we need to find our slope, right? Well, how are we going to do that? Well, we need to find 2 ordered pairs. So we have 1,140 in January and 1,440 in April, and we already said that that's 1 and 4. So our months is our X value, so that needs to go first. So for months for January, we would have 1, and then money for January is 1,140. Okay, and then our second ordered pair is going to be April and 1,440, so we would have 4 and 1,440. Now we have 2 ordered pairs that we can solve for slope. So 1,440 minus 1,140. This is the y2 minus y1 over x2 minus x1. And then we've got 4 minus 1. And this is going to give us 100. So our rate of change, we need to break this down. We know that this is going to be our rate of change, but what does that mean? If we're looking at months and money, this tells us that he's changing it by $100 each month. And you can confirm that by looking, we went from 100 to 400 from month 1 to month 4, so $100 each month, that adds up, right? So what is our initial value? Now we need to solve for B. So remember, we've got y equals mx plus b. So let's pick an ordered pair and solve for b. I'm going to use this first one. Both numbers are large, so it doesn't make a huge difference. But we would have 1,140 equals 100 times 1 plus b. So we would have 100 here, and we would subtract 100 from both sides. 100 times 1, I'm just skipping that step, minus 100. So we would get 1,040 equals b. So that tells us that we started with $1,000, $1,040. Okay, so this one's tricky. You really have to be able to know that you can put some numerical values to these months and understand what it's telling you, and make sure you pick out those ordered pairs. If it does not give you a rate word, if it does not say per or something like that, you've got to pick out 2 ordered pairs, okay? Remember that for your test. All right, and then our last problem, a tree's height in meters based on the number of years since being transplanted. All right, so it gave us a graph. So let's look at our graph and determine what this graph is telling us. So let's find some points. Where's a good point? Here's a point. And is that a point? Are we counting that? Oh, this is a point. This is actually -5, all right? So we need to, I didn't even notice that we're moving up by 2s, all right? So this is a point at -5. So we're going up to 10. So if we went from 5 to 10, we rose 5. And then we're counting by 5s down here. So 5 over 20, right? 5, 10, 15, 20. Right, so our rate of change, if we wrote this as 5 over 20, and this is time, so this is remember, we rise over run, so 5 is height. Oh my gosh, I need to go home. Height. And 20 is time. So this tells us we grew 5 meters in 20 years. But 5 over 20 can be reduced to 1 over 4. So now we've got 1 meter every 4 years. Okay. And then our initial value is our y-intercept, and we already established where this is in 5 right here. So our initial value is 5 meters, and we're putting it in meters because it is on the y-axis, which is height. All right.